Okay, we'll just go. I'm recording it. So my name's Bruce Herr. I'm senior system architect, project manager at CNS. I originally worked here in 2004, doing data analysis and visualization right out of college. And today I'm going to be talking and giving you just some fun things I've done with visualization, and just a little bit about IB Lab circa 2004. And then I'm going to explain Scrum and how you might use that in visualization projects, and sort of the utility of using Scrum in general for software projects. So yeah, I got my BS in computer science 2004, worked with Coddy. This is circa 2004. It's me over there, and Coddy's down there. So we it's where I started off at, and so us a long time ago. So I have my first project that I worked on at the IB Lab was the information visualization cyber infrastructure, which is sort of the precursor to Sci2. So when I first came in, this was before SciShell. Me and another guy, we really worked on this, and then eventually became SciShell. So we had learned a lot of lessons from creating the InfoVis cyber infrastructure, which is, if you look like here, if you looked at the old school, this was Java. This is circa 2002, 2006 to 2006. And so we basically took it. The interface is basically the same. We've added new features and stuff since then, and a lot more better technology. But so I'm the father of SciShell, some people say, and the first thing we implemented so SciShell runs Sci2 underneath, defines how algorithms are created and how they interact with each other. Pretty simple concept that we build upon to make more complex tools, which is basically in SciShell, every algorithm defines what are its inputs and what are its outputs. And from that information, we can do a lot of stuff. So, for instance, if you've got a burst detection algorithm, your burst detection algorithm may take in, say, a network, and also some parameters like what field to look at and whatnot, and then it will output another data file of some sort, usually associated with a format. So given that, once you run one algorithm, you know what the output of that algorithm is, then you can feed it into the next one and the next one. Another nice thing that we did with that is we did a whole data conversion thing that runs in the background with Sci2 and SciShell, is that our data converters, they define the format that comes in and the format that comes out. So if you convert from CSV to network workbench file format, and then we have another one, let's say CSV to Excel to NWB. So if we had those three algorithms, we create a network of converters so that we can go from format A to format B, even if we don't have a direct conversion. So if we have to go through a couple hoops in order to get from CSV to network file, it can do all of that automatically, and it uses network science sort of things, like basically its shortest path. You've got a big graph of all the converters, and we know where we're at and where we're trying to go, and then we can figure out what the shortest path is as far as the algorithms to get to that. Let's see. So that was the basis of SciShell, and create a network workbench with that. And then later on, Sci2, I think there's now like 180 algorithms, and they're all defined in this way. So that was one part of what I did back then. The other part is doing different visualizations. I'll just show you a couple of them. just for fun. And these are, so my two favorite ones, this first one is the emergent mosaic of Wikipedia activity. Let's see here. You've probably seen this before. There's a 5 foot by 5 foot poster that's not up right now, but this is Wikipedia around 2000, from around 2008, and so what we've done is created a network of all the Wikipedia articles that we could. So I think it was like at this time it was 659,000 articles, and 2 articles. So we created a similarity network. So 2 articles are similar to each other if they've been cited by a 3rd article. And so we use that in order to figure out the similarity. And so we've created a network. Maybe if I zoom in all the way, you'll see there's actually little dots. Each of those dots is an individual article. And 2 dots are drawn close to each other if they're similar based on this co-citation metric. And we're using a layout algorithm called DRL, or also known as OpenORD or VXORD. And so the first part of that, so we've got this network layer, and then the second part is we use images. So the sort of the researchy part, other than the scale at the time, was, can we use images to label a network? And so what you get, so what we did is we looked in this area, looked at in each square and found the most popular article. And I think that was the number of edits it was receiving at the time. I believe that's what it was. And so then you get these fun sort of things that are, you find the fun thing is you find one image and you look at the stuff around it and you try and figure out, like, why are they next to each other? Let's see. We go with, so we'll go up here to this top left is a pop culture sort of area. This is actually a little bit harder to read on the computer. It's a little, it was designed originally for printing, so that's a little bit why it's hard to read. But so when we laid everything out, the pop culture ended up being in the top left there. And so you can kind of zoom in and see, Brad Pitt, Marilyn Monroe, a couple fun things. And the idea with this, one thing I never did get to do with this that I want to do someday is create an online version so that when you're zoomed all the way out like this, you get larger images that are more representative of the whole. And then as you zoom in, you get more and more contextually relevant images. But overall, and I think the technique will still work these days. I think Wikipedia is it's around 3 to 4 million articles, which VXORD or OpenORD can easily handle. Let's see. And the site I'm using here is called Gigapan, but it lets you sort of take snapshots of different areas of the map. This one was a sort of weird one. Got Adolf Hitler close to Pope Benedict and Christopher Columbus and stuff. Opus Dei. So you get some interesting things. This is sort of designed just so you can like sort of just look around and find fun little facts about it. Let's see. And then another one was IMDb. So this one was also used to be hanging on the wall. With this one, we're showing all the movies and all the actors that were available at that time up from IMDb. 428,000 movies and let's see, how many did it say? I forget how many authors or actors. This was, so in this visualization, there's actually 3 layers. At the bottom layer is every movie ever made up to that time. top left being like 18 something or other, 18, let's see if I can get all the way down there, 1890. And if you zoom on all the way, you can see that they're actually, these are individual movies. And I think they're size coded according to like rating, or I forget now, it's been too long. But so you actually at the bottom, you've got every movie ever made. They're also color coded by genre, which I have the thing over here. So you've got blue is others, short, drama, comedy, documentary, adult movies, romance, and thrillers. So you see those colors all around on there. And then the second layer is an actors layer. And two actors are drawn next to each other if they've acted in a lot of movies together. But then you also get, so if these guys act, so you start to get these cliques of actors who acted a lot together. Let's see if I got this here. Yes. So these are, so this is one cluster of, let's see, I think it was like drama and something else, but from 2000 to 2004, these were all the labels are actors who received received or were nominated for an Academy Award. Those were all the labeled people, and you can see that they're that's the white dots. It's a little hard to see, but you notice that they're all sort of smack right on top of each other, and sort of the question was like, you know, are these guys getting nominated because they're all in this tight clique, or are they all, you know, is there other reasons for why most of the award winners came in that one area? Which, let's see. So then that gets to this other part, which is the third layer, which are these edges that draw from the movie down to the actors in the movie. So you can see sort of where it's pulling its actors, the actor space is pulling from to get to these movies which were nominated or won an award from 2000 to 2004. So this was just another fun visualization we did. It's sort of funny. You see this red areas, those adult films, so it's kind of like a blotch. But okay. And I have others. If you Google Bruce Herr Gigapan, I have some others, but those are two of my favorite. Let's see here. Okay. So, okay. No, I'm not a Scrum expert. I've just used it in my professional software development life, and also came to Scrum after doing a whole bunch of development that didn't go very well either. You know, this is sort of, if you go into software, production software, most of the good software companies revolve their development around Scrum. So I'll just go into explaining how Scrum works in general, but maybe try and touch in on how you might use that in a visualization project. So with Scrum, you start off with a project, and the first thing that you do is you try and figure out who the users are. You define the features that you need based on who your users are. And you create this product backlog. So for example, we're doing this project called ASOL. On the other side here, there's like 4 computers. It's not much to look at right now, but we're creating this run exhibit, an exhibit that allows kids and people at museums to, they basically what they do is they run down the hall, they choose what they want to run against, like whether that's a dinosaur or an Olympian or some other creature, and then they race it, and then at the end they see their score, but then they also get to explore these visualizations. So they're feeding into this data set that then they can then go in and visualize in a lot of different ways, and that's a way to sort of get kids introduced, or even adults introduced to some concepts with information visualization and stuff like that. So so for ASIL, we have, one of the user stories would be as a runner, while running, I want to see how good I'm doing. So you kind of define it in terms of their needs, and they don't have to really go down into a lot of detail at first. You're just trying to get, like, you want to start thinking in terms of someone actually using the software, someone actually using the visualization. What problems are you really trying to solve? So as you sort of think about this and sort of brainstorm with a group or with yourself, you'll come up with all these different needs that they have. So I need to be able to see my run, see how fast I'm running. So we need to have a nice display, in their line of sight. We also know that there will be people watching the exhibit. So you also want to consider them for your feature set. So the other thing, as an observer, as someone watching my kid run, I want to see how well they're doing as well. So that means, given those two things, we need to make sure that our visual displays are legible from someone watching from a distance, essentially. And so that sort of informs kind of where you want to go with your visualizations and stuff. So you create all these user stories, what they're called, and then with the team of developers or with yourself, you kind of rate how hard each thing is going to be. And they're numbers from 1 to like 100, and they're not necessarily in terms of number of hours it's going to take to implement, but more like how difficult a task it is, like how much thought, requirements. A 1 is like, okay, it's low-hanging fruit. We know how to put a label at the top of the page. It's something that needs to be done for it, so we're going to give that a 1. But if for being able to display the time running on the screen in a way that's visually appealing and legible, that might be like a 3 or 4. So you build these up, and during sprint planning, so each sprint you have a certain amount of time. So you got, let's say, okay, I want to do the first sprint is going to be a week, and sometimes you've got you have a choice over exactly how long it is, but you want at least a week. So you think about, rather than trying to implement the whole thing all at once, you try and figure out, okay, within a week, what things can we finish? And to go back, like the other thing with your product backlog is you organize it by priority. So the most important things are at the top, and the least important things are at the bottom. And the product backlog can have everything that you ever want to do with it. But the most important things will bubble up to the top. And the person who determines that is the product owner. And I'll go into the different roles here in a little bit. But as a team, you then decide, okay, these are the most important things. In a week, we can tackle these 2 or 3 things reasonably. And then you put that into your sprint backlog here after you've done your planning. And then the team goes away and they start implementing. And every day they have this thing called a scrum. And each team member says what they did yesterday, what they plan to do today, and if there are any problems that they're having. So everybody, that's a way to keep everybody in sync. And then the third question, like if I have an issue, if I have a problem, there's another role, the Scrum Master says, okay, let me take that care of that for you. so that you can continue to focus on your work. So let's say, for instance, you need a license for some software for the Scrum. Okay, the Scrum Master says, okay, I'm going to go get that for you, and they don't. So you get all the Scrum Master gets all the roadblocks out of the way, so that the people developing can just work. And I usually act as the Scrum Master for our development team at CNS. And one thing I sort of take pride in is that we have these things called weeklies, and that you write down everything that you've done during the week. And for the developers, if I'm doing my job, it's 100% I'm doing X. 100% I'm working on the ASIL sprint. So I get all the other crap out of their way, so that they can really just focus on the sprint goals. So you work on a small subset of your overall project, and at the end, you want to have something that you can deliver, that you can show. When you get to a certain point, after every single sprint, you could theoretically ship that product off. You could just theoretically put that visualization online, and it would have some utility. So rather than trying to come up with a ton of different features and spending months trying to get everything done, you try and find this small subset so that you can initially see the data. So this is how this would apply to visualization. Like, rather than trying to get all the different features and functionality that you need right off the bat, you try to figure out what that minimum viable product is. So what do we need to do to get that data showing visually, so that we can start to understand the data and how we can address the user needs. So then after you've finished the sprint, theoretically you ship the product, the newest version of that product. After each of our sprints, we push a demo to GitHub, so that after every sprint you can see how far we've gotten, and that keeps us honest. It lets our stakeholders, the users, see things as they're growing, and they can also see if we're going way off into left field. And that's the other nice thing about this is, like, in typical waterfall model, you're defining everything you want, and then the developers go away and implement everything and come back. But 6 months down the line, as you're developing, those user requirements are no longer true or totally wrong. So then you go back to the client and say, here's your thing. They're like, that's not what I wanted at all. And that has happened. That's happened to me probably the first time. My first project that I worked on at Chalk Labs was kind of like that. I thought I knew exactly what the guy wanted. So we went off and did that, and he wasn't very happy. We eventually fixed things, but the point is that, like, you want to have the users involved at each step. But another key thing is that your stakeholders or your users cannot add or remove anything they cannot add anything to the sprint during the sprint. Because that's another thing that you run into issues with, is that every time you make a change, they're like, well, can you tweak this? Can you tweak that? And then, you still get this thing where you're going off on left field. It's just in a different path. So by keeping your requirements set for each of those 1 week periods, or 1 to 4 weeks is the typical sprint length. By keeping those set, you don't get distracted. And they really are distractions. So, and by keeping them from 1 to 4 weeks, the furthest off you're going to get as far as your timelines and stuff is 1 to 4 weeks, which is not bad in a long-term project. Okay, so you've made your release, and then the other hallmark of sprint is continual process improvement. I think that's actually the most important piece. Is after you've done a sprint, you look back at what worked, what didn't work, and what's one thing that we can change to improve the process. So as you're doing more and more of these sprints, your team comes together and they really figure out how to work together, what works and what doesn't work. And that's really important. And so the other thing so that goes back to these estimates that you make on the product backlog, the story points is what they're called. So when a team first starts off, they may only be able to address, say, 5 or 10 story points at a time. But as the developers grow and they figure out how to work together, the number of story points they can implement increases rapidly over time. Because that's another thing that you hear about Scrum is that, well, you don't have all the, you're trying to implement this thing and you don't have all the requirements, or you're trying to implement this thing and you don't know how long it's going to take because you're doing things iteratively. But by tracking, by reviewing your progress and reviewing after each sprint, you can see how many story points you can hit during each sprint. So eventually you're able to graph that and see, if we keep on our current trajectory, we'll be able to address all the remaining user stories by, say, January. And also by looking at that trajectory, let's say 2 months before January, you can see that your trajectory has changed, and you then can go back to the client and say, this isn't quite working out. Can we remove something? Can we change it? Can we move it back? Most likely, it's usually, okay, is there something that we can remove in order to get to that goal? Because in a big project, there might be a lot of little things that aren't nearly as important. So you can go back to your client and sort of figure out, okay, we can't hit this. We're not going to, our projections look like it's not going to hit it. So what can we do? We can still meet your needs, but, take off a couple of different items. And if you're not doing this continual process of looking back at how you're doing, you can't really come to them. You may go into January and be like, oh crap, we're not going to make it. And that's not a good way to come to your client. They don't like that. So then you review how things went, and you demo. Typically, the sprint review actually is where you could do a demo to the client to let them know where you're at. The retrospective is where you're talking about what works and what doesn't work. And then you go back and you plan for the next sprint. And the other nice thing, at least for us at CNS, we have a bunch of different projects. So by getting everything down to sprints, like a 1 to 4 week sprint, we can put one project on the shelf while we're working on another project. And I can sort of plan things out based on these 1 to 4 week chunks. And because you're finished with a certain subset of that project, you're not coming into some chaos. You've got everything you implement, all the user stories that you had done are done. You're not going to come back to problems with them, assuming, you're a perfect programmer. But so then it's pretty easy to drop one project and go to the next project because things are very well defined. Let's see. So this is another view of it. I don't think it adds any real. Oh, one other thing with this, and that's got to do with the product owner, is this vision. So in Scrum, there are three main roles. There's the product owner, the Scrum Master, and the Scrum team. So in a traditional sort of programming environment, you've got a project manager who's kind of both the product owner and the Scrum Master. So this sort of splits it out. The product owner is a stand-in for your client, or stand-in for the user, stand-in for the person who's going to use your visualization. So they're the keeper of the vision, okay, and they also curate that backlog. So they're the ones that say, okay, I've talked to the users, I've talked to our clients, and based on their information, these user stories are the most important. They need to be done before we start tackling some of this other stuff. So their job is to understand what their user needs and understand the importance of those different user stories. And if there's ever any questions that you have for the client, they're the stand-in. So if you're like, well, do we need to be color coding this? I mean, this is a dumb example, but does this color coding need to be, or does it need to be accessible? Does it need to be a set of colors that, colorblind people can see or not? And they have to make that, they make that decision. They will obviously consult with the clients, but they're the stand-in so that you also don't have clients constantly coming in and trying to tweak things when they don't necessarily understand the process. The Scrum Master is a person who kind of keeps the Scrum going. They get the problems out of the way. So if any sort of blockers that the Scrum team has, their job is to make sure that they don't have to worry about it. And then they just sort of are there to teach how Scrum works and basically be the problem solver for the team. And then the Scrum team is not just software developers. This also includes designers, testers, QA, the whole, all the bits that normally go into software. And so you act as one cohesive team. And the important part too is like, you don't have a designer off somewhere else. Like they're an integral part of the team so that they understand the user stories, and they'll have tasks of their own. Like, when you first start out, you may not have a design for the visualization or for the website or what have you. So they're still an integral part of the whole process. And also data scientists, all the research stuff, that's part of it too. So it's sort of, I forget what it's called, like cross-functional teams. Okay. So a couple things and I should say, so if you're the only person and you're just doing a project, even though you're just one person, I would highly recommend sort of thinking about in terms of the product owner. So when I'm trying to think about the client, trying to think from the product owner's perspective. When you're thinking about developing, think from the developer's perspective. So even though it may just be you, these roles are still important to sort of understand, the user stories are based on the user needs and not, whatever the developer wants. And the Scrum Master, that's the mode where you're taking care of any blockers, anything that's getting in your way. And then the Scrum team is the ones getting down and doing the work. And so you can sort of think of that as three different mindsets that you would have. So the next thing, so usually when you're doing a sprint, you pull off a set of user stories, and then the development team will then break that down into actual tasks. Like, what do we actually need to do to implement this? And usually what we do is you create these Scrum Boards. Let's see if that one's... So this is probably a better example. So you've got your user stories you're going to address, then you've broken it down into actual, full tasks. And then when developer A starts working on something, he moves it from to do into in progress. And then when they've implemented it and it needs to go to QA or needs to go to someone to review, and move it into testing. I call it review in ours. So when a developer is done with a task, they put it into review, then I review it, or someone else would review it. And if it passes all the tests, then it would go into done. Another important piece with all this is having a definition of done, because some people say, it's showing the data on the screen. Okay, it's done. but does it work? Have you fully tested it? Does it truly address the issue that you're trying to implement? So it's also very important to understand what it means to actually be done, because in Scrum, at the end of your sprints, you want everything to be done. Like all the things you decided to do, you want it to be done, so that when you start on the next sprint, you're not hitting a whole bunch of bugs because you got rushed and tried to do too much, and then left bugs on the floor. So this is what you would use just to organize yourselves. And often in Scrum, you want to have this like in a public place or on a public website, like in terms of like GitHub, so that everybody can see where you're at. And I can also and as a Scrum Master, I can see, this person's been stuck on this task for like the last 2 days or like the last day. Let me see if I can go help them on this. Or if we're getting down to the end of the sprint and we have quite a few left to do, I can, or any of the developers can say, okay, let's figure out how we can fix this and get this done by the end of the sprint. You can ideally you address everything, and that's the importance of the sprint planning session, is you don't want to bite off more than you can chew. And you also want to leave time for you to test it and make sure it's clean, working correctly, well documented, all the stuff you normally want to have with a project. And as you move along, as you start developing, you'll figure out the cadence, like how much you can really address each sprint. And these sort of Scrum boards or project boards are useful just in general. Like I use this for at home when I've got chores to do and things that have to get done, but I can't really address them right off the bat. I create a little Scrum board and just at least for me, it helps me to organize my mind as far as like getting stuff done. We had some folks from ASL, this other project we were working on, and for making this exhibit over here on the other side, we were getting down to the last couple days, and it wasn't really a full-on sprint, but I started to see that we need to get a bunch of stuff done, and rather than just trying to feel around trying to figure out what to do, we created a Scrum board. We put all the stuff we needed to do. I mean, it's pretty obvious. And then when someone's picked something up, when someone was starting to work on it, they put it into doing. And then when they were done, they put it into done. So then everybody could see, we were working in that room over there, but then everybody could see where we were at and what things might fall off. So it's pretty useful. So a couple things. So how does this apply to visualization? In general, it's just a good way to structure software projects so that all these different principles really help you to create quality software, and helps you to focus on actual needs of users versus what seems like it'd be cool. How can this, I want to create this new visualization, but does it really address the user's needs? And then it allows for iterative development. You're not going off on out into left field, and you're able to deliver early on, and it's really great. It's really important because then your clients, your users, can actually touch the thing that they want you to work on, versus just hoping that at the end of the day that it's going to be something that they can use. So it gets people more engaged in the process. So let me show you a couple things that we did. So the first one is HSD, which we're actually doing a really cool visualization for these guys. Maybe I'll just show you that first because it's just so cool. Well, not super cool, but Okay, so what this is HSD is called Health System Dynamics. So our user, they have these large ontologies. hierarchies, and they wanted to see, so, and they have overlaps in their ontologies, but they're big, and so it's hard to really understand where everything is falling out at. So we're developing this tree visualization to help them see those overlaps and to make decisions on that. So one of the probably the coolest part about this though is, so you see these circles and you've got squares. The circles are actually the tree nodes, but then after that you see bars. So what's happening is each circle is a node, and everything underneath, so these bars are actually summaries of each level underneath it. So like for instance, diagnosis. This lets you know, even though you don't have this full tree expanded, maybe this will, oh, not that. Even though you don't have the full tree expanded, you can start to understand what's below, you know, what does the full tree look like. You can see medication down here on the 7th level, there's 69,549 nodes. And they're broken up into mostly leaf nodes. But then there's folders and cases. I think that this is going to be a really nice generic sort of visualization. And the other thing is our client came up with the idea. So we just sort of took what they were talking about and, you know, executed on it. So it's also something, sometimes people have a negative attitude toward clients, like they don't know what they're talking about. But if you really listen, sometimes they have some real needs and have thought about their situation, and they give you this cool new visualization. I've not seen anything like it before. So this is the main visualization framework is Vega. Vega is built on D3. And then we built this on Vega using Angular. I don't know if you guys have heard of Vega, but it's pretty nice. You can create visualizations purely in JSON. When you start to get to some of these advanced concepts, you kind of have to really think about how you're doing it. Like even expanding and contracting nodes isn't... The specification of the visualization is a JSON object. So this like if we compiled the visualization down, essentially it would be one JSON object you could give to, they have an online site where you can just give it the JSON and it displays it. And that, you guys probably haven't done WVF. WVF is the web visualization framework that we developed at CNS. It has some of those same concepts, but the idea is that you can start off with a visualization without any programming. And all of this right here was all done with one JSON file. We broke it out using JavaScript, but at the end of the, we could actually compile it and print out the JSON. So. Let's see. So they were pretty happy with this. Before I started, this had been stuck in development purgatory for a long time. So we've actually started making progress. So I'm pretty excited about this one. Does anybody have any questions on this visualization maybe?
What is the 2, 3, 4, 5 scale?
Oh yeah, so this is the levels of the levels in the tree. So the 2nd level nodes, 3rd level, 4th level, it goes all the way down to 11 levels of hierarchy. So that's what's nice. Like if you were to try and expand out to get down to the 11th level, I mean, it would be just ugly. And then when you expand it out, then you're not seeing the local well, when you expand it out, you're seeing the local nodes, but then you're losing track of the global view. So this sort of gives you both a local view of your data, like as in I've expanded out to a couple, down a couple fields, but I still have a good idea of where I'm at globally, which can sometimes be a problem in visualizations. So anyway, I really like this one. Let's see, and I wanted to show you how we organized our project. So and I highly recommend using GitHub also. It's a best practice for even if you're doing small projects. It's also good for your resume or CV, just to point people, like these are all the things I did. That's really useful. So we started off, we created a backlog, like we had talked about. So GitHub has got these project boards. If you've used Trello, it's also like Trello. We've created our backlog, and as we've started to develop, we've started to hone in on what user stories or what features are required for our phase one. So phase one is where we can integrate the project we're working on in their larger software system. So we're now starting to narrow in on what exactly has to be done to get to what they want, or to deliver something that they can use in their overall software system. Now, there's still this backlog of other stuff, really cool stuff we want to do at some point. But for phase one, we've started to narrow in on what it is we want. So, as we're developing, so we're actually on a sprint with HSD right now. I think someone's working on this right now. So technically this would be over here in progress. We don't have all the nice automation per se with this, but it's a nice, simple public tool you can use. So then our clients could come here at any time and see what it is we're working on. Now, we also have we have different project boards. So right now we're on sprint 3. And this is also really important to define upfront, like what are your goals for this sprint? Sometimes people refer to sprints like I'm working on a sprint, but they don't have any goals. So they're just running, and you don't know where you're going to get to. You don't have any goals. You're just running, and that's not a good way to do it. So you want to, upfront, find out, what are your goals? State upfront, what are you trying to do in this sprint? So we're trying to clean up the visualization. There's some label placement issues that we're fixing. We're doing cumulative size on some boxes. So those boxes right now are saying how many nodes are on each level. A cumulative option would then show at second level there are, how many nodes are at second level and below. And then when you get to third level, how many third level and below. So both have utilities. And our client brought this up in the last meeting. So we said, we can tackle this during this sprint, and then adding additional encoding options using different fields. So those boxes you saw were encoded in a certain way using a certain data field, whether it's a case, a folder, or a leaf. But we're going to give them an option now to choose other data. So anyway, those are the goals, and then you've got to do, in progress, ready, and done. So we've got 2 things that are done as of today. We started today. This one's in progress, and when it gets to ready, then that's time for me to review it. And then like I said, after each sprint, we update our demo site, and this is also hosted at GitHub. So. So the user, our client can always come and see what is the most recent sprint, like a demo. So let's see. Let's see if I've got any. I talked more about ASOL, but basically out of time. So it's the same setup basically. Any questions or comments? Okay. All right. Well, thank you guys.